A human body is consisting with 60 to 70% of water, and it is not just humans. Most animals and even tiny bacteria are made up mostly of water. Water is the key to the existence of life as we know it. That may sound dramatic, but it is true. Most of an organism's cellular chemistry and metabolism occur in the water-based goo inside its cells called cytosol. Water is not only very common in the bodies of organisms, but it also has some unusual chemical properties that make it very good at supporting life. These properties are important to biology on many different levels, from cells to organisms to ecosystems. Polarity of water molecules. Water's polarity is responsible for many of its properties, including its attractiveness to other molecules. The key of understanding water's chemical behavior is its molecular structure. A water molecule consists of two hydrogen atoms bonded to one oxygen atom, and its overall structure is bent. This is because the oxygen atom, in addition to forming bonds with the hydrogen atoms, also carries two pairs of unshared electrons. All of the electron pairs shared and unshared repel each other. The most stable arrangement is the one that puts them farthest apart from each other. At the dihedron, with the oxygen-hydrogen bonds forming two out of the four legs, the lone pairs are slightly more repulsive than the bond electrons, so the angle between the oxygen-hydrogen bonds is slightly less than the 109 degree of a perfect tetrahedron, around 104.5 degree, because oxygen is more electrogreedy than hydrogen. The oxygen atom hugs electrons and keeps them away from the hydrogen atoms. This gives the oxygen end of the water molecule a partial negative charge, while the hydrogen end has a partial positive charge. Water is classified as polar molecule because of its polar covalent bond and its bent shape. Hydrogen bonding of water molecules. Thanks to the polarity, water molecules happily attract each other. The plus end of one hydrogen atom associates with the minus end of another an oxygen atom. These attractions are an example of hydrogen bonds, weak interactions that form between a hydrogen with a partial positive charge and a more electronegative atom, such as oxygen. The hydrogen atoms involved in hydrogen bonding must be attached to electronegative atoms such as oxygen, nitrogen, or fluorine.
Good day everyone, I am Fritchie P. Bayado. Today I am going to discuss about cohesion and adhesion. So first, let's define what is adhesion and cohesion. Cohesion, it allows the substances to withstand ruptures when it placed stressed, while adhesion is the attraction between water and other molecules. Cohesion holds the hydrogen bonds together to create surface tensions in water. Since water is attracted to other molecules, adhesion forces pull the water towards other molecules. Water is transported in plants through the adhesion and cohesion forces. These forces pull the water and the dissolved minerals from the roots to the leaves and other parts of the plant. Cohesion facilitates the growth of surface tensions, the capacity of a substance to withstand being captured when placed under stress or tensions. This is also why when we put a dry surface, water forms droplets instead of being flattered by gravity. Cohesive and adhesive forces are important for the transform of water from the roots to the leaves and plants. Without the properties of water, plants unable to receive the water and the dissolved minerals. Next is all about hydrophobic and hydrophilic substances. So what is hydrophilic and hydrophobic? Hydrophilic surface has a strong affinity to water and spreading of water on such surface is preferred, while hydrophobic materials are known as non-polar materials with a low affinity to water. Hydrophilic molecules get absorbed or dissolved in water, while hydrophobic molecules only dissolve in oil-based substances. Hydrophilic molecules need facilitated, while hydrophobic molecules are suitable for passive diffusion and cellular activities. Hydrophilic molecules are polar and ionic, while hydrophobic molecules are non-polar. For an example of hydrophobic substances is thin film nanocoating, BF and cell phones, tablet. It is the actual physical barrier it creates between liquids and the important electronics component. An example of something that is hydrophilic is self-cleaning glass. This special glass has been coated with nano-sized thin film. Instead of allowing the water to form water droplets that bed up and roll off of the glass, this cool nanotechnology helps tiny water molecules to glide over the surface in a still, washing dirt or other debris away.
Acids and bases are chemicals which interact with each other, resulting in the formation of salt and water. Acid contains sour taste. In our daily lives, we use many compounds called acids, like orange or grapefruit juices, which contains citric acid. Acid is any hydrogen-containing substances that is capable of donating positive hydrogen ion to another substance. They can also remain energetically favorable after a loss of hydrogen ion. They are known to turn blue litmus into red. Base is a molecule or ion to accept hydrogen from an acid. Has bitter taste and soapy to touch. Bases that can be dissolved in water is referred to an alkali. Bases are known to turn red litmus into blue. A good example of acid is hydrogen chloride and sulfuric acid. A good example for base is sodium hydroxide and potassium hydroxide. The pH scale of water is measured in how acidic or basic it is. Ranges from 0 to 14, with 7 being neutral. pH value of acid ranges from 1 to 7, while base ranges 7 to 14. Acid are ionic compounds that break apart to form hydrogen ion in water. Solid water density. The instrument used to measure density of liquid is called hydrometer. Density is the weight for a chosen volume of a material. A common unit of measurement for water density is gram per milliliter. Its density is roughly 1 gram per milliliter. But this changes with temperature. There are substances that dissolve in it. Salinity affects the water density because the attraction between water molecule and sodium ion is stronger than the attraction between sodium ion and chloride ion in the lattice. The addition of salt to water makes a solution that is denser than fresh water. Ice density is 0.92 gram per milliliter. Density of water varies in the amount of material dissolved in it. Its ice structure takes up more volume than the liquid water molecule. Hence, ice is less dense than liquid water. Wood can also be generally float in water because it is less dense than water. Heat capacity of water. Heat capacity is the capability of a substance to absorb heat energy. Specific heat is defined by the amount of heat needed to raise. Water has a high heat capacity, which means it takes more energy to increase the temperature of water compared to other substances. The high heat capacity of water also helps to regulate the rate at which air changes temperature, which is why the temperature change between seasons is gradual rather than sudden, especially near the oceans. The high heat capacity of water has a great deal to do with the regulating streams in the environment.
day everyone, this is Maloloy-on tackling about chemistry of water. Water chemistry, or water, is a universal solvent because a lot of substances dissolve in water but not all, such as oils. Water cycle. Water cycle is how water recycles itself. It is also called as hydrologic cycle. It starts from the evaporation of the bodies of water, which then lifts the water vapor in the atmosphere, which then condenses and forms into clouds. When these clouds become denser, these water droplets falls into the ground through precipitation. Precipitation can be in the form of rain, snow, sleet, or hail. The water due to the precipitation can be passed back onto the bodies of water or be evaporated again in the atmosphere through plant transpiration as plants releases water from their pores. Or the excess water can become surface runoff, which stays in the lakes, ponds, seas, oceans, or any bodies of water and then do the water recycle again. Water contaminants. Water contaminants are the impurities mixed in your water, such as physical contaminants. Physical contaminants include sediments and organic materials. Biological contaminants are the contaminants such as microorganisms in your water. Chemical contaminants are the chemicals like bleaches, human and animal drugs, pesticides, metals, or nitrogen. Radiological contaminants. Radiological contaminants are chemical elements with an unbalanced number of protons and neutrons, which results in unstable atoms that can emit ionizing radiation. This includes cesium, plutonium, and uranium. But there are ways to purify water and to remove those impurities. We have decantation and filtration, but that is not much more safe for drinking water. But boiling is much more safer since it kills harmful microorganisms in your water. Then we have using of chemicals wherein we dissolve bleaching powder into water and then mix it to the water that we need to purify. This method is called chlorination method, which water suppliers use for them to supply water into our homes. Now you have learned about the basics of chemistry of water and learn how important water is. So let's summarize the topics that we have discussed. So we have discussed about polarity and structure of water, cohesion and adhesion, hydrogen bonding, hydrophilic and hydrophobic substances, acids, base, and pH scale of water, solid water density, heat capacity of water, water cycle, contaminants of water, and ways to purify water. So thank you for watching and may you have some takeaways from this video.